Namaste and welcome back to JEE Physics with Typical Monk. This is class 25, the dual nature of matter. For a century, light had been a wave. Then a strange experiment refused fit, shine light on a metal and electrons fly off. But only if the light's frequency is high enough, no matter how bright it is. Einstein's answer changed physics. Light comes in packets, photons, each a particle of energy. And de Broglie completed the symmetry. If a wave can be a particle can be a wave. Today, the photoelectric effect, Einstein's equation, stopping potential, and the de Broglie wavelength. One idea at a time. Here is what you will master today. First, the photoelectric effect and its laws. Second, Einstein's equation and the work function. Third, the stopping potential. Fourth, photon momentum and the de Broglie wavelength. And fifth, the Davisson-Germer experiment plus the drills. One idea at a time. 4 ideas. Run this entire chapter. Look at them together first. Light is quantized. It comes in photons, each with an energy h nu and a momentum h over lambda. The photoelectric effect, light above a threshold frequency ejects electrons from a metal. Einstein's equation, h nu equals phi plus k E max. The photon's energy splits into the work function and the electron's kinetic energy. Master line, light behaves as a particle here and matter behaves as a wave. Nature is dual. Now look at the picture, the photoelectric effect. The setup, light of frequency nu strikes a metal plate and electrons are ejected from it. The threshold, emission happens only above a threshold frequency, nu not below it, nothing at all comes out, however bright the light. Instantaneous, the emission is immediate and the current grows with the light's intensity. The photon, one photon ejects one electron and that is why intensity changes the number of electrons, not their energy. Now the equation that explained it all. The equation, h nu equals phi plus k E max. The energy coming in equals the work function plus the kinetic energy going out. The work function. Phi is the minimum energy needed to free an electron and it equals h nu naught. Above threshold. The extra energy, h nu minus phi, becomes the electron's maximum kinetic energy. Intensity versus frequency. The intensity sets the number of electrons. The frequency sets their energy. Now how we measure that kinetic energy? The stopping potential. Definition. The stopping potential, V0, is the reverse voltage that just stops the very fastest electron. The relation, EV0 equals K E max, so the stopping potential directly measures the maximum kinetic energy. Frequency link. The stopping potential rises linearly with frequency above the threshold. Intensity. The stopping potential does not depend on intensity at all. Only the current does. The graph, a plot of the stopping potential against frequency, is a straight line of slope h over E. Now look at the picture, the graph of kinetic energy against frequency. The graph plot the maximum kinetic energy against the frequency. It is a straight line. The threshold, the line crosses zero at the threshold frequency, nu naught. The slope of the line is Planck's constant, h. The intercept, extended back, the line meets the energy axis at minus the work function, minus phi. Now the other half of the story, matter as a wave. De Broglie, every moving particle has a wavelength, lambda equals h over p, Planck's constant over the momentum. Small for the large. That wavelength is vanishingly tiny for big objects, but significant for something as light as an electron. Photon momentum. And a photon carries momentum too, p equals h over lambda, even though it has no rest mass. Davisson-Germer. Electrons were diffracted by a crystal, exactly as waves are, proving that matter really is a wave. In a symmetry, light is a wave that acts as a particle, and matter is a particle that acts as a wave. Now the formulas that earn marks. Einstein, H-stein equals phi plus k E max, and phi equals h nu naught. Stopping potential, EV0 equals k E max. De Broglie, lambda equals h over p. Now match each formula to its name. H nu equals phi plus Ke max goes to Einstein's photoelectric equation. Lambda equals h over p goes to the de Broglie wavelength. EV naught equals Ke max goes to the stopping potential. And Davisson-Germer goes to electron diffraction. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. The maximum kinetic energy depends on the light's frequency. Da was a summon of K. Statement 2. A brighter light gives each electron more energy. Wrong. Intensity changes the number of electrons, not their energy. Statement 3. The de Broglie wavelength is h over the momentum. Correct. So the answer, 2 are correct, statements 1 and 3. The trap is the brighter light claim in statement 2. Now the 2 mistakes that quietly cost marks. The truth. The kinetic energy depends on the frequency. The number of electrons depends on the intensity. The trap. Thinking a brighter light gives faster electrons and forgetting that below the threshold, no light works at all. The second truth, that the Broglie wavelength is lambda equals h over p. It is larger for a slower or a lighter particle. The second trap, forgetting that below the threshold frequency, no electrons come out, however intense the light. Now, test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. Einstein's photoelectric equation. H nu equals phi plus K max. Question 2. The work function in terms of the threshold frequency. Phi equals h na na. Question 3. The stopping potentials relation. EV naught equals Ke max. Question 4. The de Broglie wavelength. Lambda equals h over p. And question 5. What proved that matter is a wave? The Davisson-Germer experiment. Let us gather it all in one breath. The photoelectric effect. Light above the threshold frequency ejects electrons instantly. Einstein. H nu equals phi plus Ke max and phi equals h nu naught. Intensity sets the number of electrons, frequency sets their energy. Stopping potential, EV naught equals Ke max, and the plot of V naught against frequency is a line of slope h over E. De Broglie, lambda equals h over p, and the Davisson-Germer experiment confirmed it. Next class, the atom, Rutherford, the Bohr model, and the hydrogen spectrum. Shine light on a metal, and it behaves not as a wave but as a hail of particles. Each photon handing one electron exactly h nu of energy. Set an electron moving, and it spreads out as a wave of length h over p, diffracting through a crystal just as light does. Einstein's equation and de Broglie's wavelength are the 2 halves of one deep truth. Everything is both wave and particle. Next class, we look inside the atom itself. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time. You will crack G. I will see you in the next class.